Hello, everyone, and welcome to Austmine's Innovation Spotlight webinar series. Today's webinar, Green Mining, is the last webinar in the series, so thank you for being here with us. I am Tammy Pisani, the Austmine Membership Manager for Queensland, and I will be your host today. Before we begin, and on behalf of Austmine and all of today's presenting companies, I'd like to acknowledge that I am hosting this webinar from the lands of the Turrbal and Yagra people. We acknowledge the traditional custodians of the various lands on which we all meet today and recognize the Aboriginal and Torres Strait Islander people attending this webinar. The Innovation Spotlight webinar series provides our members a way to showcase their innovative solutions, techniques, and technologies to see what the next phase of mining holds. Today, as we conclude the series, we'll be covering the topic of green mining, last but certainly not least, showcasing our members' achievements and expertise in technologies, methodologies, and best practices. I will be joined by 4 industry-leading member companies who will share how they are championing the eco-friendly transformation of mining operations through groundbreaking trials, developments, and strategies that are propelling our industry towards electrification and decarbonization. Joining us to share their expertise are Philip Vandenberg, CEO of Carbonix, Peter Brady, Principal Application Engineer with the MathWorks Australia, Richard Z, Director of Solarh2e, and finally, Mike Martin, CEO of PR Polymers. The format of today's webinar will include a short presentation by each of our presenters, followed by a group Q&A session. If you have any questions throughout any of the presentations, you can please type them into the Q&A box at the bottom of your screen. If your question is directed to a specific presenter, please note that in your question. This webinar is being recorded and will be shared with attendees and will be available on Austmine's YouTube channel as well. All right, well, that includes the welcomes and introductions from me. So without further ado, I would like to welcome our first presenter, Peter Vandenberg, CEO of Carbonix. Philip?
Thanks, Tammy. Thank you all for joining this webinar. Keen to bring you along the journey that Carbonix has been on over the past couple of years, particularly our focus on the mining and how we are part of the ecosystem in relation to and some of the green mining initiatives that are coming out of it. I want to discuss a couple of things very high level, and before I tell you a bit more about how Carbonix is actually participating in these initiatives. Really about what is green mining, why green mining, some of the key technologies, in particular the ones that Carbonix plays in, as well as some of the investment that's happening in digital solutions. And this is exactly where, particularly on the data acquisition, Carbonix plays, and as well as some of the other UAV use cases within mining. And I will also then give you a bit of understanding around what Carbonix does and how we help these initiatives. So really, what is driving green mining? And according to a EY survey looking at some of the top business risks and opportunities for mines and metals, which came out earlier this year, and again, at no surprise, ESG, environmental, social, and governance, as well as the license to operate, are kind of some of the key themes that are actually driving this initiatives around green mining, because they are attracting more scrutiny from investors and the community in which they operate. And it's really about helping, and getting access to better data and making better use of that data to help meet those growing expectations. And to go take one step back, if we look at kind of the particular around, green, clean energy technologies and how is that driving mineral demand, 1% of global greenhouse gases are actually emitted by the mining activities. But as you can see from the chart on the left-hand side, large portion of actually greenhouse gases are emitted through energy generating resources. And as you can see on the top right hand side, you're seeing a change in makeup of actually the minerals that are being used between traditional forms, coal, natural gas, and nuclear, and expanding into some of the more renewable energy sources such as solar, onshore wind, and offshore wind as well. Interesting, the changeover, even though transition from traditional combustion engine cars to electronic vehicles has shown a significant increase in the makeup of minerals being used. Even though the amount of moving parts has changed, minerals has significantly increased. And this really results in effectively over the next to actually achieve that target of net zero by 2050. There's about 3 billion tons of minerals and metals actually need to be mined over those next 25 years to get to that stage. And as you can see from the chart on the right-hand side, the current mining emissions, then you add the increase in mining and minerals demand over the next 25 years, as well as ore degradation, as it's getting harder to actually get the minerals out of the ground, shows the significant increase and therefore the increasing challenge actually being able to reduce those emissions in the next 25 years. And in order to achieve those goals, there are a variety of green technologies that can be utilized, anything from plant electrification and vehicle electrification to advanced materials, sustainable materials handling, smart sensors, energy efficient drilling technologies, AI, big buzzword. But I think where I really want to focus on today is around automation and control, and particularly around digitalization and data analytics, and how to achieve that. And the investment in digital solution, again, what's been seen now is starting to happen across the entire value chain. From the moment we start, planning for mining to actually also planning for how to actually close the mine. And again, coming back to that ESG theme, it's not only about building digital twins and understanding the operations more closely about what's happening on mine sites and what's also going to happen in the future on mine sites, but also looking at some of the progressive mine reclamation, where it's particularly around monitoring air, water supplies, and what the impact is going to be on wildlife habitats, deforestation, and land degradation. And this is where I think I want to kind of aim a little bit where the UAVs really play into the mining use cases. As we talked about, very much, we see it as part of an aerial sensing toolkit. There's no one-stop shop for any UAV or even an aircraft, manned aviation, or even satellite. But the three core themes is really about the assessment, monitoring, inspection, noise, pollution, environmental assessments, whole road optimization. Talk about additional data collection around for particularly on the exploration side, but also the surveying and mapping, stockpile management are part of the operations, and of course safety. Both security and emergency response and blast radius monitoring are some of the key UAV use cases. And as you can see on the right, we as Carbonix, we play into a large, what we call long-range unmanned uncrewed aerial vehicles, but we see ourselves as part of the satellite infrastructure, the manned aviation infrastructure, and also the smaller drones, and such as drone in the box. And to give you a bit of an overview of about Carbonix itself, kind of what are we doing? Our mission is really to enable effective access to that critical remote data and to drive insights from that. And the way we do this is very much we design long-range intelligent aerial systems to effectively allow those safer environment and sustainable environments for our customers. This is one of our larger drones. This is a hybrid electric and combustion engine, has a capability to fly about 10 hours and 8-kilometer range. The operating efficiencies that are gained from this is effectively we would assume to be 80% reduction in operating costs. This actually driven by utilizing multiple sensors, LiDAR, photogrammetry. We create safe operations through redundant flight systems and reliability, and also ease of deployment, and really taking that human out of the loop through remote operating centers. The way it's been designed is very much around increasing the uptime. So it's not only about being able to fly longer, it's also being able to fly more and heavier, therefore carrying those multiple payloads. And what we also see is very much that sustainable operation, right? It's really about not only reducing the carbon footprint, which I'll come to these themes in a bit later, but also the noise reduction of the actual aircraft versus, as an example, manned aviation. And what we really see what we really strive for is to help our customers provide a safer operation, more cost-effective operation, provide them with better data, and make a sustainable operation as well. And as an example, we talk about safety is really about removing those people, the human out of the loop, taking away those manual data acquisition requirements, also be able to remove the human being able to needing to travel far to actually get the data, and actually you can use an aircraft or a UAV to actually fly and obtain the data, and really focus on those safety elements of the operation. We talked about unit economics compared to traditional rotorcraft, and these are very much focused on long-range capabilities. As I saw before, there's a variety of different use cases where you have different data collection methods. As an example, satellites or traditional aircraft still have very much their place at ultra large scale. When you're looking at multi-rotor at smaller scale, they can be much more effective. And Carbonix, we really see ourselves as kind of taking a part of that long-range UAV capability and just being more cost-effective. We talked about better insights. And again, coming back to some of our, it's really about horses for courses. The satellite, has a limited frequency, limited resolution, but is very cheap and effective. Helicopters versus, again, coming to drones, where you're going up to increasing the resolution, but the frequency can be very limited. And we talked about very much, the quietness compared to how we could play versus the traditional aircraft and such as helicopters. And this has become a very important part, not only for our mining clients, but also for our power network clients. And I think the other part we talked about is the significant reduction in CO2 as well. And I think where we really want to emphasize is not just the cost saving that we have on the operations, but actually the enabler of having more frequent, higher velocity access to your data. That actually has that, kind of the reduction in the cost base through both on your operational side, on your equipment maintenance, and as well as your health and safety, where the actual impact on operating costs, that's where the biggest saving actually comes from. These are some of the other use cases that we have utilized, particularly around the mining and the utilities and the energy sectors, as well as large scale agriculture and even emerging services. Some of the clients that we've worked with to date, large part being mining is a core focus, as well as for us the power network space as well. And that is the end of my presentation. Thank you.
Awesome. Thanks so much, Philip. That was a fantastic presentation and really interesting to see all the different applications that UAV technology has along the mining supply chain mining process. Up next, I would like to welcome Peter Brady, Principal Application Engineer with the MathWorks Australia. All right, Peter, you're up.
Thank you very much, Tammy. I feel a bit like speed dating today, but good to see Philip. Very interesting presentation. I'm talking about something a little bit different. I'm talking about integrated simulation and some lessons we've learned from auto and aerospace to try and translate into the mining industry that we're working with our customers in. And it essentially boils down to multi-scale simulation. And the three domains we work in, we have to work across on the mine, on a mine side and mine design is hard real time, minutes to days, and days to years. And as we scale them up, some of the questions we start to see is the hard real time people are interested in the controls and the batteries and the motors and the microgrids. And they don't necessarily talk to the people that are working at a shift level. The shift level people know they need power requirements, they need logistics. And the life of mine people, right? We're talking days to years simulations. They're interested in probabilistic estimates of currency, climate change, weather variability, currency fluctuations, much longer timescales and probabilistics. And the key is here that really we need to integrate them, move them out of silos so that they can all be talking together a lot happier. Excuse me, I've got a little wriggler here. So let's move back in and let's look at that in a different way, as the way we think of this as an integrated and common simulation framework. So the trade-offs we see here on the increasing time scale versus increasing fidelity as we move down. Now, in a perfect world, we would be able to just run one model, but it's really not possible because a model we're running at controls might be down at millisecond, microsecond, or I'm seeing a lot of models these days in the electrical switching running at nanosecond levels. It's not possible to run that as a life of mine type process. So we need to be able to change that fidelity, decrease that fidelity to move up the timescales, but still be able to feed backwards downstream. So let's look at some examples of what we mean and how we're working with some different customers on it. So let's start at the shortest timescales. And some of the questions I normally get is like, we're talking about microgrid design. We're running power converters, power controllers. How do we handle the power fluctuations on a trolley assist haul, right? Like as we connect in that truck, we get a big surge in demand. How it drops off, we also get a big kick the other direction. How do my motor controls work? How do my control systems work on my processing plant? So what we have is a model at this scale is at a high level, looks like this. This is a fairly common model we would see working with a lot of OEMs. Is focused at this this builder. So the big truck manufacturers, the big haul system manufacturers. It's split out into a number of components. So we have the vehicle and plant model sitting under the truck here. And we have our controllers. So this is where the OEMs are building their, well, for a traditional internal combustion, this would be where your engine management system, your control system sits. Or if for an electric vehicle, it's where your battery management system and your regenerative braking system sits. So we've got this model. It's coming from the OEM. But the key we ask at this point is I talked about breaking down silos. So what we often see is, as trust builds up with suppliers and relationships, is sharing these models to bring over to then actually drive it around the mine. So we've got this. We need to be able to then take that hard real-time control model, and we need to be able to run it at those shift level scales because the hard real-time controls is not a lot of use. So this is where reduced order modeling comes in, to take those simulations from the hard real time up into the higher levels. And conceptually, it's an AI-driven process or a statistically driven process. We're seeing a lot of machine learning models and deep learning models come into this space. But conceptually, what we do is we run those high fidelity models over some indicative parameter spaces to be able to generate that AI or statistical model to then run over. What that looks like in practice, well, let's go back to the truck. So we look at particular combinations of road grade, speed, weight, acceleration, deceleration combinations for a specific truck, for all the likely combinations we want to see. And this is what a typical profile for an electric haul truck looks like. We're looking at state of charge, vehicle changes over different grades and accelerations. And then we push it through the statistical models to get the reduced order model. And the key here is that reduced order model runs significantly faster for acceptable predictions. And that's a key concept I want to get across here. Any reduction in fidelity will speed up, but there's also a concomitant reduction in data and forecasting. So it's much a decision in acceptability and a conceptual decision as to what you're happy to, what limitations you're happy to work with. So that's at that lowest level, the hard real-time control. And these techniques equally work applicably for plant control, microgrid modeling, hard real-time control of plant, movable plant. So when we step up to the next medium time scales, we're now getting the customers, we're looking at shift level, logistic scheduling, hourly power plan maintenance, looking at maintenance scheduling and forecasting. And we start to see sort of 6 to 24 hour, maybe 36-hour weather forecast loads come into this, particularly with variable renewable energies and people that are using microgrids, wind farms, and energy and process storage systems to optimize that forecast. Conceptually, let's continue using those trucks and those haul fleets as an example. This is really what a model of a mine would look like. So this is quite a simple mine. We have a maintenance yard for working with our vehicles. We have a haul in, haul out, haul in, haul up, haul out, and spoil dump. And we have our maintenance yards in here. So this is we're starting to see a combination of those hard real times in lower fidelities, as well as we're starting to see some probabilistics. So we're starting to able to evaluate how those vehicles are going to perform in practice, as well as how those charging cycles work and how those maintenance and failure profiles start to look across shift and multi-day events. And then when we scale further up, we're starting to look at longer timescales, currency fluctuations, climate change, market change, energy storage, and mine operations. And the key at this scale is we're really starting to embrace probabilistic simulations. So if we start to look at those, like currency fluctuations, these are volatile commodity prices. We start to need to be able to factor in that volatility and look at those longer time scales. So it's probabilistic innovation. And again, what we do is we scale up those fidelities, those shift levels, because we might be asked questions like, well, let's have a look at a model which we generally get asked at this. A model we start to see at these time scales is we're starting to ship products. So this is a model of a bulk operation up in the Pilbara. We get shift arrivals and we're managing stockpiles. We're looking months in advance for how we can schedule particular grades of concentrate or grades of crushed ore to make that shift. And we're starting to manage it. Now, I did note that this was probabilistically based. A key note is I'm talking about running this so far. I've been talking about running this model forward. So I'm running this model forward to generate forecasting, but I can also run this model backwards to run what if signs. How do I change my fleet? How do I run it backwards? And then once I'm doing questions about changing that fleet, that allows me to feed back down to that shift level planning and say, okay, if I want to run fleets like that, how do I, if I need to deliver this tonnage, how do I have to, what does my fleet have to look like on shift level? So to bring it all back and finish this out, I'm really talking about a common simulation framework to break down those silos, allow interaction across not just your mining, your internal companies, but really bring your suppliers, your OEMs into the fold, use the models that they've already got of the plant operations that they use to design to empower your teams to generate that multi-scale simulation. So thank you very much for your time. I'm going to throw it back to Tammy at this point.
Awesome. Thanks so much, Peter. Kudos to your assistant today.
Yes, thank you.
No, really interesting and really incredible to imagine the efficiency gains that you could get from using simulation technology. So thanks for sharing that today. All right, next up, we have Richard Z, who is the director at Solarh2e. Richard, over to you.
Thank you, Tammy. That was a really interesting one, Peter. It looks like you and I should be working a little bit closer together. Solarh2e, and thanks for everyone for attending. Solarh2e is really a new company, and it's made up of effectively our partners. And we've got 3 key partners, and our key partners are really partners that will provide us with a solution, or provide you with a solution that's an end-to-end solution for these kinds of one, simulations, 2, delivering of the trucks and the vehicles to help you decarbonize. And I can take you through some of these things, but the best thing for me to do is really to show you what exactly we do in introducing some of the OEMs. In terms of our partners, one other partner is Solarh Group, and Solarh Group's interest is really in I won't go through all this. This is something you don't need to know. Solarh Group's interest is in simulations. So when Peter Brady was touching on simulations and so on, life of mine simulations is so important because you might start with a mine which might have 1 million tons of ore being moved, and in the second stage you might have 3 million tons, and the third stage you might end up with 5 million tons. And your vehicle usage, your efficiency and so on really needs to be factored in before you go ahead and decide on huge capital expenditure on the types of trucks, types of transport vehicles taking your ore from the port, from the mine to the port. So I won't go through a lot of these with you. All I'll try to tell you is that these things are quite complex, and you've got legacy systems if you have existing mines. If you're a new mine, it's a lot easier. It's completely new. We can provide you with some of this equipment. So there's new technologies to consider. There's battery-operated vehicles that are swappable. There's chargeable vehicles as well. And also, if you have existing systems, how are those systems going to be integrated into your existing systems? I won't touch on what we're trying to reduce because that's clear. We're trying to reach net zero by 2050. In some cases, some of the larger companies are trying to reach net zero even earlier. I won't name you who, but you know. What I'd like to do is to consider putting to you the facts that right now there isn't a real solution out there that can deliver for you everything, which means your initial simulations that you need to do before committing to you know, to a big expense of capital. So that needs to be done. You also need to consider your life of mine and your equipment. Who's going to be purchasing some of this equipment? We concentrate on the transport alone, and transport is a big issue here. It's a mine within the mine transport itself, as Peter has mentioned, from the mine pit through to stockpiles, you know, and then from the stockpiles through all the way through after the processing, all the way through to the port, whether it's by rail or by haul trucks. We concentrate on haul trucks because most of the smaller mines, they rely on haul trucks. So we're trying to bring into Australia a completely new system, which has to do with swapping batteries on haul trucks. Why swap batteries? The reason for that is because if you look at charging, in Australia, we do not have the charging infrastructure to charge trucks, which are carrying, you know, quad trains and even doubles. They won't go very far. You need to stop sometime. And if your distance between your port and your mine is 200-300 kilometers, you're not going to make it. You're going to have a lot of problems. So anyway, I'm going to show you this new system that we're bringing in here. And we're actually right now looking at where to locate it for demo. So this is it.
Hi, everyone. Let me introduce you about Sany's J312 charging and swapping station. As you can see, this is a simplified version of an integrated charging and swapping station made up of containers. The station measures 12.1 meters in length, 3.3 meters in width, and 6 meters in height, occupying an area of about 40 square meters. It includes 3 compartments, 1 buffer compartment, and 2 charging terminals. The entire station can charge and swap up to 22,400 kilowatts per day, making it suitable for small-scale fleet operations with 10 to 30 vehicles. Next, let's check out how a battery is swapped at the station. As an electric truck enters the station, it authenticates itself using an ID card. After adjusting the posture of the vehicle, the high voltage is turned off and the station sends an unlock command to the battery locking mechanism through the T-box. After receiving the command, the T-box on the vehicle side opens the locking mechanism and sends a feedback signal to the station, indicating that the locking mechanism has been released. Then the station starts the battery swapping process.
Apart from the ability to swap batteries quickly, this charging station also supports charging replenishment through its charging terminals. The standard configuration of the station includes 2 charging terminals, capable of simultaneously charging 2 vehicles. The maximum charging power can reach 300 kilowatts, and it can fully charge a vehicle with battery capacity of 282 kilowatts in 1 hour. The charging terminals can be expanded up to 8 as needed.
The whole battery swapping process will only take 5 to 6 minutes. The other highlights of the station are included. 1, it is flexible and versatile. The station is suitable for various short distance transportation, such as logistics parks, cargo stations, and batching plants. The number of charging terminals can be added according to the specific needs of the site, up to 8 charging terminals. Second, independently developed with high cost effectiveness. The station is independently developed and manufactured by Sany comprehensively, allowing Sany to have full control over its costs to provide high cost effectiveness. Third, fast construction and relocation. The station can be set up within 12 hours. Fourth, simple and reliable integrated charging and swapping. The station is equipped with 3 battery swapping stations for quick battery swapping and 2 charging terminals for vehicles. The station can charge 3 batteries and 2 vehicles simultaneously. Fifth, highly compatible battery swapping mechanism that is suitable for a low temperature environment. The station can serve various types of vehicles, such as semi-trucks, dump trucks, and concrete mixer trucks. Sixth, free operation platform configuration design. The station comes with a complementary station control and operation management platform, which offers vehicle and station management along with data analysis. The platform records detailed data on daily station usage, providing customers with statistics for investment and operational ROI calculations. That's it for the J312 charging station.
So let me quickly also summarize that. First, we've got our partners. So our first partner is Solarh Group. Solarh does the simulations. They're a complex engineering firm based out of Canberra and Adelaide with about 100 technologists employed. And what they do is that they would look at the whole life of mine operation and simulate it before anything happens. Simulate with kinds of trucks, kinds of prime movers that you may require. We don't really look at the mining operation at this stage because I think that's covered by a lot of other OEMs. What we intend to cover is really the transport from the mine through to the port. And we do this by providing swap stations along the route, hooked into solar farms or with other renewable energy. So we'd like to separate two things. One is the charge stations. That particular infrastructure doesn't have to be carried by the miners. It doesn't even have to be carried by the fleet operators, for example. Fleet operators just come in, swap their batteries, get charged, and swap out again. So that's the way we operate. We try and bring three things: the simulations, followed by the OEMs and the vehicles, and thirdly, followed by the financing. So as one of the investors in Solarh2e, it is Resource Unicorns Capital. And so Resource Unicorns Capital can also provide the financing for not just the trucks, but also the swap stations. So what we really are doing is we're doing everything. We're doing simulations, we're looking at the renewable energy storage, we're looking at the swap stations, we look at the prime movers and trucks that you might want. We provide you with integration for remote monitoring into your systems if you have existing systems. And of course, with these days with data, there's the big issue of communication. So we provide that through our partners. And finally, the financing. So effectively, it's a one-stop shop. So what are we doing? We're looking for opportunities. It's new. We're looking towards replacing legacy assets. We're looking towards new assets, new vehicles being supplied. We're looking at mitigating the risks relating to how you would want to implement such a complex system. So we may do a full demonstration for you in terms of the digital twin, and we can move that forward. We're bringing the systems, the trucks and the swap stations into Australia first half of next year. We'll find investors for you if you require them. And finally, it's a whole of systems approach. That's really what we do. That's the outcome: progressing electrification of haulage operations, cost savings, reducing a carbon footprint, environmental impact, meeting and surpassing environmental regulations, exceeding customer and stakeholder expectations, expecting to reach net zero by 2050. That's what we're trying to do. So if anyone out there wishes to have systems like this, just contact us. That's really it. Thank you so much.
Great. Thank you so much, Richard. Really innovative automation technology around electrification. Thanks for sharing that with us today. Before I introduce our last speaker, I'd like to remind everyone that there is still time to submit your questions if you have any for today's speakers. All right, next up, our final presenter today is Mike Martin, CEO of PR Polymers. Over to you, Mike. Mike, you may be on mute. You want to check that?
Hello.
All right, we can hear you.
Oh, thank you. Today's presentation is for those wanting to know how to address the reduction in CO2e in the production blasting, generally the most overlooked aspect in mining chain, when air decking and blasting. By the end, you will have tools to reduce your CO2 equivalent in preparation for the newly legislated federal reporting system for companies from the 1st of January 25. BHP has a climate transition action plan from 2021, and on page 23, they list the emissions that they are going to aggregate and report on. We'd like to just focus on two today. One is methane and the other one hydrofluorocarbon, HFC. Mara mine has had 3 disasters in its lifespan, and mainly caused by high buildup of methane. The hazard, if not managed, can be fatal. However, methane has benefits on mine sites in the form of generation of small energy transformers, burning methane for small plants, conversion to methanol, which is gathering a lot of interest in the maritime industry for low emissions. And thirdly, what we're interested in is the production of dimethyl ether, or DME, which is utilised in our patented systems for an alternate to HFCs. The detection of methane has been enhanced with satellite identification, one being launched recently called Carbon Mapper, the company. And I've seen some interesting Australian plumes in that. The other alternatives, the methane sat, which is being sponsored partially by the New Zealand government, but it doesn't come online until early 2025. This piercing of what we call top hole bags in production holes has a number of issues, one being the safety aspect of piercing these highly inflated pressurized bags. The other one is emitting HFC directly into the environment, which is contrary to the EPA regulations for car air conditioning. Why this goes unnoticed, we're not quite sure. This incident at Isaac Plains was recorded on regional ABC, and you can see in the distance that plume event, which is referred to in the industry as a NOx, NOx, where it's a combination of uncombusted oxides of nitrogen. That fume is looking for moisture to condense into nitric acid. So that particular mine also uses a HFC-based blast bag, which is decomposed into toxic HFC, which is also looking for moisture to produce hydrofluoric acid. Dr. Gunther Paul addressed the incidents, identifying the hazards in that report, which fortunately didn't go unnoticed by a decomposition expert by the name of Neville Taylor, who identified some of the breakdown products in the blast. The temperatures are high, but the blast is only 1 or 2 milliseconds. And in that time, HFC can decompose into some nasty products, including R23, which has a 100-year global warming potential of 12,400. It makes it difficult to achieve zero emissions by 2050. The recognised technologies for destruction of HFC in this column range from cement kilns to plasma arc, which is run at 3,000 degrees centigrade for 20 milliseconds. This is a schematic of what a plasma arc destruction unit looks like. The HFC is converted to HF and washed through a alkaline calcium hydroxide solution to form calcium fluoride, which is eventually used as a fertilizer. So it can have a benefit in that regard. But the salient point is the Montreal Protocol requires a 99.99% efficiency for destruction of HFC, and a mine production hole cannot achieve that in a blast. On the anniversary of the signing of the Montreal Protocol on the 16th of September this year, the United Nations Secretary General pointed out the need to avert a climate crisis by mid-century, and by ratifying the protocol for the Kigali amendments, we have to do more to achieve that. And this is an exercise we did for a medium-sized to large coal mine in Queensland, when you can compare HFC imported bags with our DME-based product with a global warming potential of 4,144. The number of bags per month produces 20,289 tonne of CO2 equivalent compared to DME1. And over the next 25 years to 2050, that could translate to 507,175 tonne of CO2 equivalent that you can avoid in your calculations or your reporting. The bottom of the can has the weight of gas. So when you do the calculation, it's not difficult to put those figures in, multiplied by 4,144, and over the 25-year period up to 2050, you can get an idea of what reductions you can produce to reduce your CO2 emissions while you're perhaps still working on your methane reduction. The figures are overwhelming, and at the very least, we should apply the precautionary principle, which is the lack of full scientific certainty should not be used as a reason for postponing a measure to prevent degradation of the environment where there are threats of serious or irreversible environmental damage. The industry has been led to believe that the synthetic greenhouse gases are entirely destroyed as part of the explosion for which they are deployed, without any relevant scientific evidence to support such a claim. However, top hole bag piercing goes against that fraudulent claim.
2 weeks later,
and this is an interesting little graphic of how we stopped using CFC
when the plane
and
had
introduced the Montreal Protocol.
Ozone dropped, chlorine levels soared. They'd found the smoking gun.
This was flying over the Antarctic on multiple flights, collecting data to show that ozone and chlorine don't like each other and were creating the ozone hole. Furthermore, ozone depletion didn't stop. with the release of refrigerants, coolants into the atmosphere, as reported by Dr. Margaret Herzitz and her colleague, Dr. Paul Newman. The full paper is in the YouTube article below. Our answer to that is a green product, we call CoolCat, global warming potential of 1. And its other benefits are it's load testing when it's in a hole. We load tested with 1,766 kilos over 21 days for Australian standard and 28 for US. We have a customised inflation timing for the client depending on your site conditions. And we tick the ESG boxes of managing your carbon and climate change vulnerabilities, health, safety, environment, ethical supply chain and sourcing, and governance, risk mitigation and management, and ESG reporting. If you require any assistance for your transitioning, you can email our ESG address at prpolymers.com. Thank you for your attention.
Fantastic. Thank you, Mike. A very relevant presentation, given the impending regulations that you mentioned, and obviously a very practical solution for mines to be reducing their emissions now. Fantastic. All right, now we're going to move on to Q&A from the audience. So let's see what we've got. Right. Looks like we have first up a question for Philip. Philip, you mentioned you process data faster. Can you elaborate on what data processing Carbonix does?
The short answer is none, actually. And the reason we are very much about collecting the data. There's a bit of pre or post-processing that we do to get it in the right formats, depending a little bit of whether it's lighter or photogrammetry. The reason why we talk about increased velocity, about getting the data faster, it's very much working through cloud technologies where we actually bring the data from the drone towards the cloud that can then be directly imported into the respective GIS system that the client will use.
All right, great, thank you. We have another question from the audience. This one is for Richard. The recording said that the station is suitable for low temperature environments. How would this work in the Pilbara?
In fact, I did answer that, but I'll answer it again. It actually works up to 52 degrees centigrade. So hopefully it doesn't go higher than that, because if anything that's higher than that, no one's working anyway. So, and you don't want to be working at 50 degrees centigrade. So there's no issue. In fact, most of the electric vehicles, they operate within that range. Even the Teslas. Hopefully that answers that question.
Great, thank you. This one's for Peter. Peter, when collaborating across suppliers, how do you manage IP?
Yeah, look, that's a very good question, and trust really, and it's an evolution of trust. So we see a spectrum of options from starting relationships with little trust. We see compiled binaries that move a model across, so it's just a black box. And as that evolves and you get that trust and relationship built up with a supplier, it opens up both into a more bi-directional process. So it's a spectrum, and it really just comes down to trust and collaboration.
Great, thank you. Mike, we have one for you. Where can I have my GHGs measured by an independent third party?
Yeah, in Queensland, there's a company that falls under the mining inspectorate called Simtars at Redbank. They have mobile measuring equipment that they take on mine sites, and they're a third-party contractor if you want to avail yourself of their services.
Great, fantastic, thank you. All right, Philip, what are the barriers to adopting long-range drones into morning operations, and how has Carbonix overcome these?
Yeah, I think it's not only the regulatory environment part or initially, I think a couple of years ago, it was very much a technological issue. Now we're looking towards as a barrier to adoption. Now we're finding that, those barriers are dropping. Regulations such as, CASA getting BVLOS approvals, that's where we're allowed to kind of operate at scale, are becoming easier, or kind of there's more of a process. However, we're in close contact with CASA on these things as well, where if you look at what we have coming down the pipeline in terms of the amount of area that needs to be scanned versus the amount of kilometers that needs to be scanned, and there needs to be, we work on a more effective solution. But these things, like with we've got BVLOS approvals with some of the larger mines up in Queensland and down in South Australia. So it's definitely, it just unfortunately takes time. It's not necessarily a barrier to adoption. And then of course also where bars audited as an example, that's part of, and not only the scrutiny that we get through that audit, but also the other internal audits that we almost get from the customers around, being compliant with their internal risk systems as well. And having worked with the BHPs, the RIAs of the world, we are able to kind of slowly but gradually go through those processes as well, and get them more comfortable around utilizing and adopting the technology.
All right, fantastic. Thank you. All right, it looks like we have come to the end of our time today. So I would very much like to thank everyone for being here, and I hope you enjoyed today's webinar. As a reminder, this will be posted on our YouTube channel to watch the entire Innovation Spotlight series, to explore more groundbreaking solutions, techniques, and technologies that are shaping the future of mining, and discover what's next for the industry. I would like to give a big thank you to Philip, Peter, Richard, and Mike for sharing their time and expertise with us today. And finally, a big thank you to all of you who joined us and attended, and we look forward to welcoming you to another Austmine webinar in the future. All right, thanks again, and enjoy the rest of your day.